I'll emphasize in math that the most important thing you can do is problem solving, not reading. So I would always just jump to the end of the chapter and see if you can do it. If you can't, you'll always find examples. But this is one of the most important skills you can learn. And if the first differences are all the same, it's a linear. If the second differences are all the same, it's a quadratic. And then sometimes you have to, later on, you're going to learn to look at third and fourth differences. But your first thing you want to be careful of is, do your x's go up by 1? That's the first thing you should check. Otherwise, your data is going to be distorted. And you also have to subtract this minus that. If I do this minus that, I get plus 4. But it's clear these are going down by 4. So that means it's like that. And this is going down by minus 4. And this is going down by minus 4. And it's obvious they're all the same, which means this is my first difference, the first time I took a difference between the y's based on 1x. And I discovered minus 4, and if that's the first difference, then we're talking about a line. And I can even see within here, there's my b right there. So I can do this, and I'm going to skip m for now. And I can also see it's going down 4y for each 1x. So that's a slope. So right there, I'm able to come up with the formula from this, and because they gave me the Y-intercept. This one looks like it's going to be the second differences. So that first one's a linear. If I look carefully, my x's are going up by 1, and these are going up by 2, then 3, then 4, 10 minus 6, 4, and then 15 minus 10, 5. So that's not linear. But the next one, they're all going up by 1. Okay? Which tells me this is a quadratic. And the standard formula for a quadratic, and I want to teach you now that you can find the formula of this, is this. That's what you want to start with. And there's an x squared over here. But right away, I know that when x is 0, this is going to be my y-intercept, and they happen to give me that. So I can rewrite this last part as plus 6. So far, so good. Now, how would I discover a and b? Well, they give me a bunch of data points. So I'm going to go on to the next data point, which is 1. And even minus 1 would be a good one to use. And 1, if I plug in for x and 10 for y, I get this. What's 1 squared? It's 1. So I get 1a plus 1b plus 6, which is just this. Which means that a plus b is equal to 4. Which means b is equal to 4 minus a. So now I have one equation and two unknowns. So all I need is a second equation. Okay, well, I can start with this again. And I'm going to just use 2 because some students have trouble using minus 1. So I'm going to use 2 for x and 15 for y. And I get this. What's 2 squared? 4. Get the number to the other side. Okay, I get this. And now up above, though, I have a formula for b, which means I can replace this with the formula I have up above. This is called substitution. And now 2 times 4 is 8. And 2 times a is minus 2a. 4a minus 2a is 2a. 8 to the other side is 1, which means a is equal to a half. And then I can put it into this formula right here. So it's 4 minus a half. And I get 3.5. Which means I have my a, b, and c now. And I can either write it like this. 7 over 2. Or I can write it like this. Either works. And we might as well discuss how do I well, no, I'm not going to use this one to complete the square. We'll use a different one because this one's more complicated than it looks. But right away, when I test these numbers out, this formula works. Okay. Here we go. go on to the next one. Oh, and I'll show you an example of what happens when the x values go up by 2. But anyway, it's clear that these are going up by 4. 8 minus 4 plus 4. 12 minus 8 plus 4. 6 minus 1. So those are all the same, which means we're dealing with a line where y values are increasing by 4 for each unit of x value. And I can see when x is 0, y is 12. So right away I have the line formula. But what happens when I'm missing every second x? What happens when my x values are going up by 2? Well, so long as they're consistent, you can still figure it out, except you'll have to realize, oh, these are going up by 2, which means my first differences are multiplied by 2. And you can see it when I do it here, right? It's going up by 8. However, we know the first difference is actually 4. But if I divide it now by how much my x's are going up, they're going up by 2, I get the right answer, 4. And so just be aware of your x data when you're doing first differences is what I'm saying. Okay, well this is clearly going down by 3, 4 minus 7. Then it's not anymore, it's going down by 1. Then it's going up by 1. Then it's going up by 3. So this is clearly going to be a parabola, and I'm going to guess that the vertex is between 0 and 1. And when I take second differences, so since the first differences are all different numbers, it is not a line. When I take second differences, that's going up by 2. It's hard to see, but minus 3 to minus 1 is plus 2. And just subtract it. Minus 1 minus minus 3 is minus 1 plus 3, which is 2. And then this next one is 1 minus 1 to 1, which is plus 2, and plus 2. And right away we can see we've come up with a parabola. It's a quadratic. And now if I go back and look, I can see it when x is 0, y is 3. So I come up with that. And if I use 1, I get this. When x is 1, y is 4. Bring the 3 to the other side. It's plus 3 here. Other side becomes 1. And so I just have another formula again. 3 minus a is equal to b. And then the next line, I use the next value. I can see that when x is 2, and when that's squared, it becomes 4. I get this. And by the way, y, when x is 2, y is 7. Bring the 3 to the other side. I get 4. Oh, that's 2b, by the way. And now, if I replace b by the formula I have up above, I get this. Plus 6 minus 2a. And then when I subtract the a's, I get that. And when I do this, I get 2a is equal to minus 2. So a is equal to minus 1. And up here, if a is equal to minus 1, then b is equal to 3 minus minus 1, which is 2. No, which is 4, rather. Which means I can complete my formula. Y is equal to negative 1 x squared plus 4x plus 3, which means it's a downward facing parabola. And I'm going to show you a little bit about completing the square. Completing the square is all about perfect squares. And if I have x plus 2 and I square it, I'm always going to get the first term squared plus 2 times first term and second term plus the second term squared. So what is that going to look like? Well, what's the first term squared? X squared. What's 2 times x? 4x plus 4. Now, that means that every time I have x plus 2 squared, I get this 4x, which, by the way, is 2 times this number when there's no number in front of x. And I get the square of the last term. And it's only when x is pure, x has no number in front of it. Which means to go backwards to deduce what, if I'm just looking at this, to deduce what the perfect square would be, it'll be half that number. And you'll learn that every time. For instance, x plus 3 will always come out and I won't do them all. It's going to come out as x squared plus 6x. It's going to be plus 9. Just remember this first one's x squared here, which means I can see that's twice times my number. So to go backwards, I just take half of what's in front of my x to figure out my perfect square. Well, the problem is right here, if I'm going to take a perfect square of this, it's best if I don't have a number in front of my x squared or a negative. So I should factor out a negative. And I'm going to get negative x squared minus 4x minus 3. That's what happens when I take a minus out of all that. And then if I'm just focusing on this and I remember my perfect squares, that there is always going to come out as a result of x minus 2 squared. Right? X minus 2 squared is always going to come out as x squared minus 4x plus 4. That's what x squared is always going to come out as. And I can see I have part of that there, but not the plus 4. So what you do is you say, okay, let's move this. And actually, when I factor out this minus 1 here, like, yeah, I didn't have to include the 3. So we're going to pretend that I didn't include the 3. And we're just going to leave the plus 3 way over here. And we're going to instead assume I only factored out from there. Well, I can see I've got most of my thing that I want. I'm just missing this. So I'm going to do a little bit of math magician, which means in math, I can just add and subtract the same number, and I don't affect it, which means I can add a 4 and subtract a 4. And then don't forget plus 3. So this actually does not change my equation, because if you look at them, they add up to 0. So long as they add up to 0. So far I've got this. Now notice that I have exactly what I need to go backwards from this to that. So I can replace everything in red with that. So now I've got this. So I got that, and it's got to be a little squared up here. So the problem is, though, this minus 4 is technically still inside, trapped in this whole bracket here. But I did convert that to that, which is great. I just got to get this minus 4 out with the 3. And to do that, you have to multiply by whatever number that is up here. So as a final result, I get this. When I multiply minus 4 by minus 1, I get plus 4 plus 3, which is plus 7. Which means by completing the square, I've discovered that the vertex is 2, 7. I'm going to let you in on a couple tricks. You can also get the vertex by taking minus b of whatever your original equation is. So I'm going to take my original equation right here. Your x value of vertex is also going to be minus b over 2a. What's my b? 4. So minus 4. What's my minus 2a? Well, my a is minus 1. Oh, no, just over 2a. What's my 2 times minus 1 going to be? Minus 2. What's 4 divided by minus 4 divided by minus 2? It's 2. And sure enough, you discover your x value of your vertex. And then if I plug it in, 2 squared is 4 times minus 1 minus 4 plus 8. So that's plus 4 plus 3, 2, 7. This is a trick to get the vertex. You can also reach this stage and say, okay, my x value of my vertex is 2. I'm just going to plug it in, and that would be called partially completing the square. So you can skip all this number stuff. When I partially complete it, I get 7, and I can just rewrite it like this right away. Just an aside. Let's see. Yeah, okay. I spent a lot of time on that because I actually think first differences are under-taught, and it's very valuable to learn how to come up with equations from first differences if you know what you're looking for. State where each parabola opens up or down. So that's just going to be determined by the negative sign in the beginning or positive. That opens upwards. That has a negative, and just make sure your x's are written correctly. So when we expand this, that's going to be x squared. So it's going to be negative 2x squared, which means it faces downwards. And that has a negative in front, so it faces downwards, and the vertex here is minus 5, comma minus 1, the vertex. And this has positive in front and no other trickery, so it's facing upwards. And 0, comma minus 1 is the y-intercept. Given this, state the zeros, the direction of opening, and whatever. So just checking the factors, I see that they're written in the correct order. So the direction of opening is downwards. The equation, well, let's look at the zeros. The 0 are going to be anything that makes that bracket 0, which means a 2 as x will make this bracket 0 and make the whole equation 0. Or a minus 6 as x will make this bracket 0 and the whole equation 0. Therefore, the zeros of this are called x is equal to 2 and x is equal to minus 6, but you can also write them like this. That's one, and that's another. And if you look, those fall on the x-axis. And if you want to find out how far apart they are, or their midpoint, add them together and divide by 2. Minus 6 plus 2 is minus 4. Divide by 2, minus 2. The midpoint between those two is minus 2, which happens to be the axis of symmetry. And also happens to be the x value of the vertex. Now I can plug in minus 2 in the equation. Minus 2 right there. Minus 3 is minus 5. Minus 2 plus 1 is minus 1. Let me get that straight again. Yeah. So minus 2 is the axis. And so that means, oh yeah, this is the equation I should be using, sorry. So minus 2 is minus 4. Minus 2 plus 6 is plus 4. That makes minus 16 times minus 3, which makes plus 48. So that means x comma minus 2 comma 48 will be the vertex, and it will be facing downwards. And the equation of the axis of symmetry I did. The zeros I did there. Given the parabola on the right, state the vertex. You can always find the vertex. It's going to be the highest point. It's going to be right there, and that's a 2, minus 2 rather, comma 3. So that's the vertex. And then the direction of opening, it's opening downwards. The equation of the axis of symmetry is the same as the x value of the vertex. So it's x is equal to minus 2. That's it for that one. That one was relatively easy. And then practicing is the best thing you can ever do. If you want 90s, you should do all the questions, or 90 to 100. If you want 70 to 60, do at least three questions of every number, not of the whole chapter. By 3, I mean 1, 2, 3. Move on. And if you want 70s or maybe lower, just do 2. But I would suggest if you get it right, you can move on. But if you get it wrong, keep doing more. By the way, YouTube, very good resource. Use it. Desmos, very good resource. Use it. And Math Symbolab, very good resource. Use it. Express each in a standard form. Graph of these. Okay. So some of them you might mistakenly think are in standard form, but you can see that there's no other x in this. And when you have no other x in here, it's kind of the same as this formula, which is the vertex formula. It's just that there's no y vertex, so it goes through 0. This is the vertex. 0, comma, minus 3. So now that we have the vertex, that helps. We can also say, well, we can instantly also know that this vertex is the y-intercept. So it's going to go on either side of there. and it's facing upwards. If we want to figure out a couple values of y, well, this one's a little tricky. Let's look at when y is 1 in this formula, we get x squared minus 3. So keep in mind this is x squared. And when I add 3 to both sides, I get 4. So x squared is equal to 4. And when you take a square root of something, you must add both values. You must say, well, if I take a square root, x can be plus 2 and x can be minus 2. That's because if I square minus 2, I still get 4. Therefore, there's always two possible plus minus values when I square root it, which means I have another point here. And the reason I took 1 was because it was easily square rooted when it became 2, which is 2 comma 1 and minus 2 comma 1. And that's enough to graph it. If I was going to graph it in red using this thing over here on the left, I'd put in my vertex right there. And then I would put 2 comma 1 here, minus 2 comma 1 here, and then just put, something up here. Like that, a little bit off. So I'll do that. Still a little bit off. Bit better. There we go. So there we go. I would have suggested making y 0, but when we do that, we get the uncomfortable situation of x squared is equal to 3, which means x is equal to the square root of 3, or the negative outside square root of 3, which are the x-intercepts. I chose y is equal to 1 because then it would become a 4 on this side, and that's easy to square root it. Kind of trickery. You can also just sketch it by taking a couple points of x, putting it into the equation. All you need is 2 other points other than the vertex. All right, what about b? Okay, how would I sketch this? Okay, so also another thing I always suggest is have a graph or graph paper. Makes your life easier, even for drawing. Graph paper is better. And just zoom out a bit until you lose the ones. And when you take a picture, you can just put it on your thing, maybe even lower it. There we go. So right away I can see this is downward facing, and the vertex is minus 3, comma minus 4. The y value is always as you see. What you see is what you get, and the x value is always the opposite. So minus 3, minus 4 is right there, and it's facing downwards. So the next couple points will be that way. But also of note, the axis of symmetry is the same as the x value of the vertex. And if I wanted to just plug a couple numbers in, I could. So we're going to take, since we know it goes downwards, we'd take numbers lower than minus 4. So let's plug in minus 6 for x. Minus 6 plus 3 is minus 3. Minus 3 squared is 9. Multiplied by minus 1 is minus 9. And then minus 4, so minus 13. Which means for minus 6, so minus 6x, it becomes minus 13. So it's off my graph. So I probably should have taken an x. Let's just take an x close to minus 3. We'll take minus 4. So minus 4 is 1 squared times minus 1, minus 5. So it's 1 comma 5, 1 comma 5, minus 4 comma 5, minus 5, which means on the other side of the axis of symmetry, the exact distance will be there. You could take another one if you want. It's minus 4. It's going to be minus 8. And over here, it's going to be symmetrical. But you really only need 2 other points along with the vertex. Always label them. So at this vertex, you should label your point like this. Whatever point you take down here, you should label. and do a better job of labeling than I'm doing it. And you should label your axis of symmetry for full points. I mean, if you're going to take math, you should get the full points, no? Right? I would think. Okay, let's go to the next one. This they give us in, they obviously want us to practice different versions, right? So if you look, when x is 4 here, you're going to get a 0. So that means we put a dot at 4, 0 and label it. And when x is minus 2, how do you find the distance between 2 points? You add them together. By the way, you want to label these 2 points. You add them together and divide by 2. So 4 plus minus 2 is 2, and divide by 2. I'll do that again in a second, sorry. Anyway, 4 plus minus 2 is 2, divided by 2 is 1. So that means the axis of symmetry is going to be here. Which means the vertex is going to be at 1. So when 1 is here, we get minus 4 is minus 3. When 1 is here, we get positive 3. So you get minus 9 times 2 is minus 18. So it's way down here, and it's opening upwards. It's way down there. So you'd probably take one other point, but if you have more graph paper, the vertex is good, and then you label it 1, minus 18, and then you just connect them and try to make it look like a vertex. And that's, I didn't do it, but there you go. All you need is 3 points labeled, and your axis of symmetry should be labeled as well. And what about something complicated like that? We already did that, right? This looks annoying, right? But it's not really. That does not have any other x's in it, so that means the vertex is right there, 0, 4, and it opens downwards. So that means the y-intercept and the x axis are the same. By the way, ignore these y-intercepts there. Let's get rid of them now, actually. There we go. So that means 0, 4, and it's going to open downwards because of this negative. And this, we need, since that's also going to be the axis of symmetry, a couple good x values to take our 1. So what's negative a half? Let's take 2, actually. 2 squared is 4, times negative a half is negative 2, plus 4 is 2. So you get negative 2, 2, which means right here is another point, and I can just tell you right now that positive 2 is going to be a 2 as well. 2 squared is 4, times minus 1 is minus 2, plus 4 is positive 2. So that's enough points right there. If I wanted to find the x-intercepts, here's what you would do. What values y when x at the x-intercept? 0. So first step, divide by 4. Or sorry, subtract 4. And then sometimes students have trouble with this. They start dividing out by a half. The easiest way to get rid of a fraction is multiply by its reciprocal. So that way the 2 will cancel out, the minus will cancel out, and the 1 will cancel out. And that I have to do it to both sides. So that means I'm multiplying the other side by minus 2. So that means you're left with this. X squared is equal to 8. And if I take the square root of both sides, x is equal to the square root of 8. And x is equal to the negative square root of 8, which, by the way, is very close to 9, so we're close to 3. So it's roughly here, not quite, and here. And that's how you find the x-intercepts of a parabola in vertex form. there like that. Do that a bit, something like that. Not bad. Not quite a parabola, but that's okay. And then label everything. Label every point and label your axis as symmetry for full marks. Okay, going on to this. So in standard form just means expand it, right? You're just going to expand it. So you're going to get used to binomial expansion. A plus B squared. A plus B, so it doesn't matter what those are, will always come out, and this is very useful to learn. A squared, so the first term squared, it's going to end in B squared, and the middle is always plus 2 times the first and the second term. So it's always going to come out like this. So you just square the first term, square the second, the last term, the second term, and in the middle it's 2 times both terms. And of course, A minus B, well worth learning. Squared, I'm going to skip the squared. Square the first term, square the last term. You'll notice both the terms are just like the one before it because they're both plus, and then the middle term is minus 2AB. So this will be the only difference of a binomial of A minus B. You might say, well, how is that useful? You just memorize those two, or essentially sort of know that that's the case. And then if this is the first term, you put it in for A. If this is the last term, you put it in for B. So already I can tell you first term is going to be x squared, last term is going to be plus 1. And 2 times minus 1 minus 2 times x, minus 2x. When you learn that expansion, that's not a minus, that's just part of the x, it's a lot easier than writing it out and expanding each time. So learn this. This is the first level of binomial expansion. You'll even come up with more ways of doing it. So now we've got this for the first one. I've expanded the binomial, and it became as this. When I multiply the minus 3 to it, I get this. When I add the numbers together, I get this. And don't forget, we've got a minus in this front here. There we go. So that's the expansion. Now, it really helps to learn your binomial expansion, so that makes that first step quicker. So this one, you could multiply the 4 through first, but I would rather just expand these terms. And then multiply them by 4. And don't forget your squared. There you go. To determine the parabola, examine the parabola on the left. Well, I kind of wrote a red thing on it. Let's see if I have my... No, let's see if I can just grab it. There we go. Okay. Grab it separately. There we go. Get rid of the questions up top. Examine the parabola on the left. State the direction open, downward. Name the coordinates of the vertex. -1. Always check the labels down here. -1, comma 8. So -1, comma 8. List the values of the x-intercepts. They looks like going through -3 and 1. State the domain and range. So domain of all parabolas is XER. And depending on which way it's facing, it's y smaller or equal when it's downwards facing of what the y of the vertex is. And the y of the vertex here is 8. If it was facing upwards, it would be bigger and equal, but it's facing downwards. If you calculated the second differences, what would their sign be? Well, because this is going down and going down, their sign would be negative. Because their rate of change, that's what differences are. Their rate of change is going down. But just to make sure, you could take some values of it. Um, Determine the algebraic model for this quadratic equation. So there's two ways to do that. So we have some clear points here, right? We've got this as the vertex, and that is this. Now, there's another way to come up with the algebraic model. First, you could just type the vertex model. Now I happen to know the values of the vertex, so I'm going to just put them in right here. But what don't I know? I don't know the value of a. However, I do have a nice point right here, 1, 0, that is on this graph. So I can replace the y with 0 and the x with 1. So this becomes 2 squared. So now I get this. And then I get this. So that means I can just replace my a in the vertex formula right up here. So that's one way to do it. Other way to do it, we know the factored formula also has a mysterious a here, is this. And that's a -1 here. So now to figure this out, I can take any point other than the intercepts. Well, I have that nice vertex up there. So this is going to become -2 times +2. So again, it's going to become -4. And look at that. A is equal to -2 again. And I could rewrite it. There, I have the equation. I don't have to take a T cell to do that one. Out of curiosity, let's just have a look. So -1, 8. So here's the vertex formula. See if you got it right. Yeah, there's the y-intercepts. There's that. We're going to take the first differences. And yeah, we'll do it from this. We'll even add a couple down here. So I want to make a point. Okay. So +2, -2, -6, -10, -14. Second difference is 4. Sorry, -4, -4, -4, oh, yeah, that should have been, yeah, -4. So we can see the consistent second differences, and they're negative because it's going down each time. Pardon me. Here we go. So I ask you to do it again with 8 and 9 here. Examine the parabola on the left, direction of openings up. Find the coordinates of the vertex. Looks like 2, 0, and 0, 0. What is the equation of the axis of symmetry? Right here, x is equal to 1. State the domain and range. XER for domain. Range is going to be, here's the vertex. It's at looks like -3. So 1, -3, which means y is bigger or equal to -3 because it's opening upwards. If you calculate the second difference, what would the sign be? Positive, because it's going, the rate of change is positive, it's going up. That's all they ask. They don't, oh, coordinates of the vertex. Good, that's it right there. 1, -3. They don't ask us to figure out calculate the thing. Each pair on the points x are the same distance from the vertex of the parabola. Determine the equation of the axis of symmetry of each parabola. Okay, so that means they're equidistant of their vertex. So add them together, add the x values together. 2 plus minus 2 is 0. Divide them by 2, 0. So the axis of symmetry for that one is x is equal to 0. What about the next one? Minus 5 plus minus 9 is minus 14. Divided by 2 is minus 7. That's where the axis of symmetry will be. 18 plus 6 is 24. Divided by 2, 12. Minus 5 plus 1 is minus 4. Divided by 2 is minus 2. Minus 6 plus 3 is minus 3. Divided by 2 is equal to negative 3 over 2, or negative 1.5. And then the last one is a little tougher. We can't add those, so that's a good point. Let's look at that one right here. So I have to add these fractions together. But your fractions, you have to make the denominators the same. So to turn this into 8, I have to multiply it by 2, but I must multiply the top by 2 as well. So that becomes a 6 over 8 and 11 minus 11. So it's a minus 11 plus 6 all over 8. So that's minus 5 over 8. And then I must divide it by 2. So when you're dividing a fraction by 2, it's really 2 is 2 over 1. And I cannot divide fractions, so I have to take this top one and multiply it by the reciprocal of that. 2 over 1, the reciprocal 1 over 2. But here's another easy step. Any fraction divided by 2, just double the denominator. So that's the axis of symmetry. How do I know? Because it's called the axis of symmetry because 2 points on either side equal distance from the axis of symmetry, or 2 points with the same y value will have equal distance to the axis of symmetry, which means the midpoint is the axis of symmetry, and the formula for a midpoint is x1 plus x2 divided by 2. Complete the table. So that's all. All this means is we got to find minus 2 and determine the y value. Okay, so if I look at x is equal to minus 2 and just trace it up, I get 3. Same with minus 1. If I trace it up, I get the vertex, 4. Which means as I go up, this is going to be a 3. I can tell you that already, but I can see it right there, 3. And 1 is hard to determine, but it looks to be about 3/4 there. And then 2 is way down here, and it looks to be close to, but it's not. You know what? It doesn't quite. It's more like 4.5. So it's minus 4.5. Now, when I'm calculating the second differences, I actually like to put it vertically. That's just me. So I'll put my x's, and I'll make sure my x's are all going down by 1. And they are minus 2, minus 1, 0, and 1. And I'm just going to bring this up a bit. There we go, right about there. And I'm just going to, there we go. And the last one is 2. And then if I rewrite my y values, I get 3, 4, 3, 3/4, and minus 4.5. I'll probably just use the first ones. Plus 1, minus 1. Boom. So it's going down. It's facing down. And just knowing it's a parabola, I'm going to tell you that the first difference is there. The second difference is minus 2. So that means it's facing downwards. And so if I because it's negative, I can tell it's going to face downwards. And I can tell looking at those numbers, or looking at the graph, it's downward facing, so I knew it was going to be negative. Doing the equation, it's easier for me to do the vertex form than it is to take the first differences. Because it's a precise point. And then the other precise point I can see on there is the Y-intercept. So I'm going to use that. 0 plus 1, which is 1, and 1 squared is just 1. So I get that. Then when I subtract 3 and 4, I get A is equal to -1, which means I can just rewrite this equation like this. And there, that's the fastest way to get the equation, because those are the purest points. You always want to use the exact points, most exact points that you can. Okay, you're going to get a lot of height of rockets questions. Parabolas are used a lot in study in high school for things that go up and fall down, bridges, and you're going to get a lot of costs. Optimization costs. You're going to find the vertex is going to be the most profitable price of a product, and you're going to discover the x-intercepts are the profit loss spot. Height of rocket is shown by this. So I always suggest this when doing these things. Always see if you can factor something out to make your life easier. First of all, this is facing up downwards, isn't it? So we can expect it to go like this. And I'm also going to tell you immediately it's going to go through 0, 0. But the first thing I can notice is I can factor out a -4, and I can factor out a t. So I can do it like this, and I'm left with t minus 8. And if I focus on just putting this t in brackets, that's a factored form, which means that it's going to hit the x-axis when t is equal to 0 and when t is equal to 8, which tells me the rocket took off at 0, 0, flew through the air, and landed at 8, 0. Now I want you to use a little bit of logic here. What's its peak? Well, these have the same y value, so its peak is going to occur halfway between the 8 and the 0. 8 plus 0 divided by 2, 4. So the peak is going to be at 4. And when I put 4 into the equation, I get -4 times -4. So I get plus 16 times 4, 32, 64. So you're going to discover the peak of this rocket is right there. So you can see by factoring it, I got all the information. Rocket took off at 0, 0, reached a peak at 4, 64, and hit the ground at 8, 0. Graph it, sure, okay, I'd just put it in a graph. I'd plot these points, I'd mark it, I'd mark my axis of symmetry as x is equal to 4, and I'm done. How long will the rocket be in the air? 8 seconds. How do I know that factor there? You can also, I'll now show you how to do this in a second. How long will the rocket be in the air? 8 seconds. How high will the rocket be after 3 seconds? So for this, you need to punch in the 3 here. You get 3 squared is 9. 9 times -4 is minus 36. And then you put the 3 over here. 3 times 32 is 96. So, 18, yeah. And then when I add them together, I get 60. Almost reached the peak of 64. And guess what? If this is a vertex or parabola, and that's the peak, and it hits 60 at 3 seconds, and it hits peak at 4, then at 5 seconds, it's going to reach that 60 height again. And then what is the maximum height the rocket will reach? 64. But let me show you another situation that they often ask. They might give you a height. They might say, when is the rocket 20? When is the rocket 20? So that means you would put over here 20 is equal to actually, let me put this into the decimals first, just to show you. So you get y is equal to minus 4t squared plus 32t. And I'm just going to do y, and it'll accept the t. So there's 0, there's 8. Notice that when I factor it, I get the exact same graph. Exact same graph. Now, I'm just going to find a nice usable height here. Yeah, okay. 15 is good, so 30 is probably good too. Just a second. Yeah, 30 is good. So f of t, f of 1, 28. Okay, there we go. So, if I ask you when is the rocket 28, if you have it in standard form, you've got to put it all on the same side. This is 4t squared, by the way, and this is 32t. And if you put it all on the same side, I get where the t is 4t squared is positive, I get this. Quickly, I can factor out a 4 out of everything. Still t squared. So I got this. And just remember, this is t squared, this is t squared, and this is still t squared. And then I can quickly see, as I said, my factors here are going to be t, let's see, what adds up to 7 and reaches minus 8. This. So that means the rocket's going to reach a height of 28 meters when at time 1 and time 7. So let's see if that's true. So I'm going to set y is equal to 28. And we discover it crosses the rocket on the way up, hits a height of 28, and the rocket on the way down at 7 seconds hits a height of 28. So you're going to get that question a lot as we go, and the secret is putting the height on the left side and then turning it into a factorable quadratic. And they give you one where you got to invent the quadratic. I hate these. I don't really think they serve a purpose, but whatever. Okay, it's just about stretching your imagination. So that's the axis of symmetry. There's an x-intercept. So we got x plus 3. 32 is the max value. So they gave us the vertex. Here's what they gave us. Since the axis of symmetry is that and the max value is that, they gave us that. They also told us it crosses the axis of symmetry at this point, which means if this is a max value and the y is up, this is facing down. But if I use the vertex formula, I get this. Fortunately, they gave me the point, 3, 0. So I can do this to figure out a. And that's as plus 1 squared. What's plus 1 squared? It's just 1. So I got a, which means a is equal to negative 28. So that means I've got this as a formula. If I did that right, I think I did it right. Now the secret is you put it into a formula graphic calculator. Excuse that little mark there. And you see if you achieved all your goals that they wanted you to achieve. can't remember if that was the thing I wanted. Minus 28, x plus 1, and 32. Okay. And then you just kind of hit a home button to see. Nope, I got it wrong. So I have to try and see what I did wrong there. Oh, and they want the Y-intercept. Okay, well, there's that as well. But let me just go back and see what I did wrong. So if I plug this into the formula. Oh, yeah, what am I doing there? It ends up being 3. It ends up being 0 over here and 3 for x. So I don't know what I was doing there. Foolish. That's just from being tired. So if I put in 0 for here and 3 for x, I get 4 squared plus 32. 4 squared is 16. 32 goes to the other side. That was dumb of me. And divide by 16, I get a is equal to minus 2. So I actually just get this. My bad. There you go. So now let's put it into here and see if I got the values I wanted. So they didn't tell us that one, but they did indeed tell us that one. I'm going to put an axis of symmetry in, and we'll see our vertex. And there's our vertex. So we hit all the conditions they wanted. And now, oh wait, they wanted the y-intercept. So the y-intercept is easy because it's when x is 0. So you get 1 here, 1 squared times minus 2 plus 30, so 30. So at 0, 30, it will hit the y-intercept. Let's see if yeah, there we go. You could also do this in the factored form and figure it out, but I find the vertex form much faster. Okay, well, let's factor this one first. Okay, so the intercepts of this one are 0, 0, 2, 0. The axis of symmetry is at 1, and the vertex is 1, minus 2, I think. Or is it 1 plus 2? Hang on. Minus 1 times 2, I think it's minus 2. Yeah, it's minus 2. Okay, this one over here, the axis of symmetry is 1, so they have the same axis of symmetry. The vertex is 1, 2, so not the same vertex. And then the to figure out the x-intercept, you set y to 0. And when I subtract 2 from both sides, I get this. That's squared. So just to get back to it, this is what I started with. Y is 0 when it hits the x-intercept. This one here is squared there, don't forget that. Subtract 2 from both sides, I get that. Divided by minus 1, I get that. Square root, you got to square root it. Both sides to get there, so I get square root of 2. And then I got to add 1. So you can see that and it's negative, sometimes it's negative square root, so I get 1 minus the square root of 2. And 1 plus the square root of 2 as the x-intercepts. And so you can see that that is not the same x-intercepts at all. The only thing you'd want to check are see if their y-intercepts are the same, and you'd have to expand them to see. And y-intercepts are easy to check. It's when x is 0, but I can see right away that this is the y-intercept for this one, and for this one we're going to get minus 1 squared, which is 1, plus 2, it's going to be 1. So they don't share the same y-intercepts either. Okay. Might as well finish it off. The first, second differences of a quadratic function with a domain range of this are given. So in this case, they've limited the domain and the range. So you have to keep that in mind. With they're telling us when f is minus 2, we got 19 for y. Copy the table and complete the second row. Okay. This is working backwards when you know the first and the second differences. Great. Let's work on a separate page for this. First of all, because the second differences are all the same, it doesn't matter. They're all going to be 4. And if you look, minus 10 plus 4 got minus 6. Minus 6 plus 4 got minus 2. Minus 2 plus 4 got 2. 2 plus 4 got 6. So that means 6 plus 4 is going to get plus 10. So we can fill in the 10 there. And first differences also say that the same thing happens. So if I'm subtracting 10 here from 19, I get a 10. Then if I'm subtracting 6 from the 10, I'm going to get 4. Then if I'm subtracting 2 from the 4, I'm going to get 2. Then if I'm adding 2 to the 4, I'm going to get 4. And then when I'm adding 6 to the 4, I'm going to get 10. And you can go on forever because the next one's adding 10. And then you could figure out all the second differences and then all the first differences, and you could figure it all out. Determine the missing values of the function. Okay, I just did. Now, if you wanted to figure out the equation, you could as well. But they didn't ask me this, so I'm not going to do it. Just go see the other one. Okay, this one. So this is the profit question I was saying. So keep in mind that vertexes have a max value when they're facing downwards. And a lot of questions will be about finding that vertex to find the max profit. So it's given by this. We can see the vertex right here, 3, 50. So we might as well mark that down. Where y is given, where x is in thousands of dollars of computers sold. The company's profit in thousands of dollars in sales stairs is modeled by, that's profit. And I guess it's also modeled by this other one, minus x minus 2, which means down below we're going to have 2, 0 and 7, 0 as the y, or x-intercepts rather. Calculate the maximum profit the business can earn. What? But you gave me the profit. Such a strange question. Oh, actually, you know what? This one's different. That's different from this parabola, because those two meet at 3.5, 4.5, and this one's max is 3, 50. A company's profit on sales of computers is modeled by this function. The company's profit in thousands of dollars, so the profit base of x, I think they just rewrote it where, on sales of stereo systems, and the first one's computer. Calculate the maximum profit the business can earn. Okay, so I guess they want to see where they both can combine, like which ones. Okay, well, let's expand this first one, or the second one. So you got x squared minus 9x plus 14, all multiplied by actually, let's leave it like that. So you got a negative in front of it, like that. Let's push the 14 aside. And we can do this, minus 4.5. is going to be the square, and then if I put 4.5 in there, 2.5. Let me make sure I'm doing this right. Hang on. And then it's going to be plus. Yeah, and if I put 4.5 in there, I get 2.5 times 3.5. That's not quite right. Well, I'll just add there. 7 plus 2, 9 to 4.5. Yeah, I got the right thing. 4.5, and if I put 4.5 in for that, I get 2.5, and if I put 4.5 in for that, yes, I do get 2.5. Okay, so it's 2.5 times negative 2.5 times negative 1. So this would be the plus 6.25. So he's making 50,000, and he's making 6,250. And he's going to make the most profit if he sells 4.5 stereos, and he's going to make the most profit if he sells, 3,000. Yeah, 3,000 computers and 4,500 stereos. That will be their max profit, because the Vertex is the max profit. Weird question. They threw me off. And the last one, 16. Jim has a difficult golf shot to make, so he's got to probably aim upwards like a parabola. His ball is 100 meters from the hole. Always draw, by the way. Always draw when you're lost. So Jim is standing here, and I'm going to guess that Jim counts as origin, which means he's going to be 100 meters from a ball, which is going to count as 100, 0. That's my guess before we start. He wants the ball to land 5 meters in front of the hole, so at 95, so it can roll to the hole. There's a 20-meter tree in between his ball and the hole, 40 meters from the hole. So there's a tree 40 meters from the hole right here, and it's 20 meters tall. So it is at 60. It's about there. So at 60, what's the height of the tree? It's 20 meters. So it's 20 meters tall at 60, because it's 40 meters from the hole. And 60 from Jim's ball. With the base of the tree as the origin, write an algebraic equation to model the height of the ball with the base of the tree as the origin. Okay, so that's going to be counted as 0, 20. 0, 20, which means the bottom of the tree is 0, 0, which means Jim is actually standing 60 meters to the left of origin, which is negative 60, 0, and the tree is 40 meters from origin, so 40, 0. So they've essentially just changed the origin. I started with Jim the golfer being origin, and they turned the tree into the origin, which means the golfer's 60 meters that way, and the tree is, or the flag is 40 meters that way. But he wants to, keep in mind, he wants to land it here, which is 35, 0, 5 meters from the hole. Height of the ball, if it just clears the top of the tree. So that means 0, 0. That means we want to come down here and touch here. That's kind of weird. So I guess kind of like this. Now I can tell you the height's going to be there, and it's going to be on this coming down, because halfway between there, 35 plus minus 65, is 20 minus 25 divided by 2, so it's minus 12.5 will be the height, well, the x value of the vertex. Okay. We can just write it in factored format like this. And I'll just make it a little bit bigger. And I happen to know that where he is standing and where he wants to land the ball will be the points, because it's not the flag, right? It's 5 minutes before the hall. We just got to figure out A. Now, fortunately, they gave us the height of the tree as a point that the ball goes through. So that means when the height is 20 and x is 0, we're going to get 60 and minus 35, like that. Yeah, okay. Which means I just got to figure that out. That's huge. I think I got it right. Okay, I got that. And it's going to be negative A. That doesn't seem right. So I'm just going to try it once. Yeah. Well, I wonder if I could do it where I take the... Yeah, that would take a while. I'm going to just keep doing it like this way. So A would be that. I don't think I got it right, by the way, but 20 divided by 2100 negative. So it's saying A is that. Now, if I want to just express it as a fraction, it would be this. Because that's the simplification of this. Divide them both by 10. Divide them both by 2. Which means, if I'm right, and I don't know if I am right, this would go up where A is. So let's just see if I'm right. I actually have a feeling I'm not right. And now I'm just going to put a line at y is equal to 20. Yeah, I'm way... Oh, no. Because remember, the tree's at origin. Okay, let's just see if... Yeah, it's going to land there. Let's see if the max height is... Yeah, the max height's where I thought it would be. And the takeoff is there. Okay, it did work. That is indeed the formula there. We could have also figured out the... After I figured out the x axis of symmetry by averaging 35 plus negative 60, which is negative 25 divided by 2, negative 12.5. I could have then put it into a vertex format. I couldn't figure out the height, actually. So I don't know if that would have worked, because I'd need a formula to do that. So yeah, I think factored form is the only way to do it. So there you go. And surprised that was the fraction. And that's how you do these things. You got to kind of feel your way around them, and the more you can draw, the better.